So now let's go on to collision response. Now in physics, they'd often teach that when you have the two things colliding, you can, there's these elastic and inelastic collisions, which I'm not going to get to. So first so let's say they're going like this, and then using the physics, you can find some velocities that they're going to bounce off, and then they're just going to keep moving to their final destination. But there's a couple major problems with this. First of all, you'd have to remove the units first, otherwise it's going to detect a collision again afterwards, and that's going to make a big mess. And the second problem is that people don't bounce off each other. I mean, like, you don't just go in a straight line to your destination and then wait until you've actually hit the person and then let the physics bounce you off and then go to the destination again. That just wouldn't make sense. So, actually, a better way would be to check for the collision beforehand. Oh yeah, as for the removing the units, that would look okay if you check for collisions every frame, but with thousands of units you can't afford to check collisions every frame. So that's another advantage of checking for collisions beforehand. So let's say the units start out here, and then you can define some frames separate from the game rendering frames on how often to check for collisions. And then, let's say when they collide, you take... I need to draw this bigger. Okay. So let's say it predicts that on the next frame they're going to be here. So you take these distances and you push the units back by that much. So then the units would be over here. And then you say, instead of going to this position, you go to these new positions instead. And that works really well. Now, now another thing that's pretty popular in games... I need a new paper. But another thing that's pretty popular in games is something called steering, which is very similar. So, let's say this unit's going this way. So it'll check... I need to make this unit closer. So it'll check a point in front of it. And if that point is inside someone else, then it'll change the angle that it's moving somewhat and then steer around it. So, and as you can see, these have some similarities to each other, so I wouldn't be surprised if Medieval 2 Total War uses some interesting combination of these. Now another important concept is the ability to handle multiple collisions with when one unit's colliding with multiple other units. So let's say we've got some cliffs here like this. This is from a top-down view. And we've got this huge formation here and this huge formation here, and we tell them both to travel to the opposite side of this canyon thing. Now obviously there's this bottleneck here, so there's going to be lots of collisions going on at the same time, but you still don't want the units colliding. So an extreme case would be something like okay, let's just ignore these for now. this unit trying to go that way, and this unit trying to go that way, and they both collide with this unit at the same time, and it's got to be able to handle that. Now, one problem with the algorithm we discussed so far is that if we just apply the collision response at one unit at a time, there's a very good chance that it's going to move it into the other unit. So like let's just do this on a line. So let's say it moves this unit a little that way, this unit a little that way, because it checks for these two first, and then moves that unit a little that way, and then it moves this unit back that way so that it's colliding with that unit again. So you've got to be able to get around that, and doing so is outside the scope of this video, but I just wanted to let you know that the problem exists. So now we've found how to find the mouse position on the map, how to find the final position of the unit, and how to get there, and how to handle collisions with them. Which is okay, except there's one very important thing missing: combat. So let's give these units some maximum health, and then see if they collide with each other. They're going to subtract some health from each other, which is okay. Except right now our collision response is optimized for separating people from each other. So if you have some huge, I don't know, 100 units in a formation attacking a huge 100 units in a formation, they're just going to form this big mess in the middle. But really that's not what happens. What happens is that they stay in formation, but the front fights the front, and that way you can form these sorts of shield walls. And this isn't just in Medieval 2 Total War, but in other games as well, because the melee units would have to be able to block other melee units just from traveling through them. Otherwise, tactics like taking advantage of choking points on maps won't work. So this is kind of obvious, maybe, but it's important also that when they collide, they must stay there for some specified amount of time as they subtract health from each other. And so, yeah, so they go to the point where they're not colliding, and then they just wait there for a moment as they make their attacking move, and as that's happening, they subtract the health from each other. So that's simple, but it's important.